Have you ever stopped to think about how an app on your phone goes from, just a handful of users to managing literally billions of posts, photos, and messages? Well, it all comes down to its blueprint, its core plan for organizing data. And today, that's what we're diving into, the fundamental database models that power pretty much everything we use.
All right, here's our game plan. We're going to start with the big problem everyone faces with data growth. Then we'll look at the early, kind of clunky solutions leading up to a massive revolution in thinking. After that, we'll check out some specialized models and finally, figure out how you choose the right blueprint for the job. Let's get started.
So, Section 1, the data organization problem. Every great app starts with a simple idea. But success? Well, success brings this huge challenge. How do you keep things running smoothly when your data explodes from a few entries to millions?
So picture this. Your app is a hit. It's growing like crazy. You start with a few friends, then a couple thousand users, and then boom, you hit millions. That simple list you were using at the beginning, it's not just slow anymore, it's becoming a total liability. And this is the absolute core challenge. How do you build a system that can handle that kind of growth without just completely falling apart?
So, how did the first engineers even try to solve this? Well, they did what any of us would do. They started with models that basically mirrored how we organize stuff in the real world. Simple, intuitive ideas. The first and maybe most obvious approach was what we call the flat model. Just imagine one single giant spreadsheet for your entire business. Every customer is a new row. Their name, their address, their city, those are the columns. And look, for a small business, this is perfect. It's simple, it's clean, you get it instantly. But here's the massive catch. What happens when, say, 10,000 of your customers all live in New York? Well, you end up typing New York 10,000 times. This isn't just a waste of space, it's a ticking time bomb. Because if that city name ever changes, you have to find and fix it in thousands and thousands of places. This one problem, data redundancy, was the big thing that pushed people to find a better idea. So to solve that redundancy problem, designers came up with the hierarchical model. The easiest way to think about this is like the file system on your computer. You've got a drive, that drive has folders, and inside those folders you have files. It's a really strict parent-child tree. An item can live in one and only one parent folder. And this structure is super fast and efficient, as long as your world is nice and simple. But reality is messy, right? What happens if a product belongs in both the electronics category and the home goods category? Or what if an employee actually reports to two different managers? The whole model just breaks. This super rigid one-parent rule, well, it was a dead end, and it forced developers to come up with something completely new. And this brings us to the relational revolution. All those limitations of the early models, they led to a breakthrough that would pretty much define the next 40 years of software development. The core question that changed everything was this. What if data didn't have to live in a strict top-down tree? What if you could link any piece of information to any other piece of information, flexibly? And that right there is the genius of the relational model. Instead of one giant, messy spreadsheet, you create lots of small, separate tables. You have one table just for customers, one for products, another one for orders. Then you connect them using a special ID, a key. It's exactly like having different bins of Lego blocks. You got your wheels over here, your windows here, your bricks over there. You can combine them in an infinite number of ways to build anything you can possibly imagine. This model became the undisputed king of databases for decades. Its flexibility and its reliability were a total game changer. It allowed developers to finally build the complex, powerful applications that we all rely on today. For the first time, the way you stored your data could be just as agile as your business itself. Okay, so once we got a really flexible way to store all this data, a brand new challenge popped up. How do we analyze it quickly and efficiently to get, real business insights? This is where these analytical models, like the star schema, come into play. So imagine you have a central table of facts, just a massive list of every single sale your company has ever made. This table is then linked out to what we call dimension tables, which just describe those facts, like who the customer was, what the product was, and exactly when it was sold. This thing isn't built for making a single sale, it's built to analyze millions of them all at once. And if you want to take that idea one step further, you get the Snowflake schema. This model breaks down those dimension tables even more. So for example, a single product dimension might get split into product category, brand, and supplier. The whole goal here is to get rid of every last bit of redundancy.
which makes it incredibly efficient with storage space. So the choice between them really comes down to a classic trade-off. The star schema is simpler and way faster for running reports and analysis, but it uses more storage space. The Snowflake schema, on the other hand, is much more storage efficient, but all that extra complexity can sometimes slow your queries down. It's always this balance between speed and efficiency.
Now, before we wrap up, let's take a quick look at an alternative path, an evolutionary road not taken, so to speak. It's a model that actually came before the relational one, but was trying to solve a lot of the same problems. And this is the network model. You can think of it as the hierarchical model's superpowered and kind of chaotic cousin. It actually allowed a child record to have multiple parents, which created this big web or graph of connections. It was a direct shot at solving that tricky many-to-many relationship problem. So if this thing was so powerful, how come we're not all using it today? Well, the answer is just one word: complexity. Actually, navigating this web of connections was an absolute nightmare for programmers. It was incredibly difficult to get data out of and a real headache to maintain. And in the end, the elegant simplicity of the relational model just won out. Okay, so after this whole journey through these different data blueprints, we're left with the most important question of all. Which one is the best? How on earth do you choose? And the most important takeaway here is this: there is no single best model. Period. In engineering and in system design, everything is a trade-off. Are you building for maximum flexibility? Or for raw query speed? Or maybe for just ease of maintenance? Every choice you make prioritizes one of those things at the expense of another. So the real goal isn't to find some magic silver bullet. It's about picking the right tool for the specific job you're doing. Need a simple contact list for a small club? A flat model is totally fine. Are you mapping out a clear company org chart? Hierarchical works perfectly. Building the next big web app? You're probably going to go relational. Need to run lightning-fast business analytics? That's what Star and Snowflake were literally born for. And that really brings us to the final thought. These models we've talked about, they are the foundational building blocks of our entire digital world. Understanding their strengths, and just as importantly, their weaknesses, is the very first step to building anything that's meant to last. So thinking about the next problem you want to solve, which blueprint are you going to choose?